Okay, this is the second part of chapter 22, and we're going to do a test. In this case, it's going to be a 2-prop z-test. So first of all, let's read this and figure out what's going on. So the question is, are teenagers going deaf? In a study in 1988 to 94, there were 3,000 students. 15% of them showed some hearing loss. And then they did another study in 2005-2006. 1,800 teenagers, 19.5% showed some hearing loss. So do these data give convincing evidence the proportion of all teens with hearing loss has increased? So we have to say, hey, there's a belief being stated here, there's a claim, and so we are going to do a test of some kind. There's definitely two proportions here that are mentioned, 15% and 19.5. We're comparing the two. We're trying to figure out if the second one is bigger than the first one. Has it increased? So we're going to start with the null hypothesis here. So we're doing a 2-prop z-test. We're comparing proportions. So first thing you might want to do is define what P of 94 is. That's the proportion of teenagers in 1994 study who have hearing loss. P of 06 is the proportion of teenagers in the study that was done in 2006, proportion of teenagers that have hearing loss. So you have two ways of stating this. You don't have to state both ways. A lot of students will say it this way. They'll say, well, the proportions are the same. The null is nothing's unusual. 94 and 06 have the same proportions. That's the null. Nothing unusual going on here. I think there's a little better way to say it, and I think I would say it this way. And since we want it to increase, we're expecting that this was 15 and 19, so we're expecting this to end up being kind of a negative number here if the alternate is true. But right now we're just saying, hey, nothing's unusual. These are the same proportions probably, and so we're going to say that's the null hypothesis. The alternate is that 06 is greater than 94, so the proportion of the most recent study will be larger than. And that was what our sample said, but let's start going through the test and see what happens. So we've done P and H. A is assume the conditions, so let's talk about the conditions for this particular one. So if we're doing conditions here, we might start with something like, of course, random. Were they randomly selected? They were randomly selected teenagers. Is it less than 10% of the population of teenagers? Here, yes, certainly way less than 10%. Then we go through NP and NQ. NP is greater than or equal to 10. In this case, you have a choice, really. You could probably use either one. It might be better to use the pooled value. You would be able to get away with using this percentage as well. So if we want to do NP for the 94 year first. So first let's talk about 94, so that would be 3,000. Oops. That would be 3,000 times P hat, which is 0.15, which I think is 94. No, 450. Well, we think that's greater than or equal to 10, and when you do it, it is 450 is greater than or equal to 10. Now let's do NQ. Greater than or equal to 10. This is again for the 94. So this would be 3,000 times Q, which is 0.85. Greater than or equal to 10. And that will be whatever 3,000 minus 450 is, which is what, 2,550, I think. Greater than or equal to 10. We also have to do, so that would have been, that was 94, and this is 06. And now we're going to go 06, so this would be N P hat greater than or equal to 10. So this will be 1,800 times 0.195. Should be greater than or equal to 10. When you do that, I think you get 351. Greater than or equal to 10. So that one passes, and then Q hat. n equal 10. We have 1800 times 0.805 greater than 10. So we have whatever 1800 minus 351 is, that's 1449 equal 10. And there's one more condition. We've got this one checked off, this one, we've got at least 10 successes, failures. You want to have independent groups, especially with this particular one. Just make sure that your groups are independent. I don't think the people in 94 have any effect on the people in 2006. It doesn't sound like it's the same group of folks. So we got our conditions. Now this is where tests for two prop z intervals get a little bit difficult. There's a couple things that we need to do. But typically, hypothesis tests, proportion 1 minus proportion 2 is going to be 0. There's no difference. That's the null. We may hypothesize that there is a difference between those. And that means the standard deviations for each proportion are the same. So if the null was true, is what we're saying here. If the null was true, the standard deviations for the proportion would be the same. Since this is the case, we're going to go ahead and pool our data together. So let's see what that looks like. So p hat is really what we're looking for here. We really need p hat pooled instead of just, p hat, normal p hat. We need to combine our results, basically. So we're doing success of the 94 study plus success of the 06 study plus the number in the 94 study and the number of folks in the 06 study. And we're just going to plug those in to get those values. In AP Stat, we only pool when we have the difference of two proportions, and it's a hypothesis test. Don't you dare pool for confidence intervals or really any other test. It's kind of dangerous. This is the one case where we're going to pool in AP Stat. So we're going to go through the progression of plugging the formula here. So here's our formula. Oops. So if you see, here we go. Plugging in the numbers there, we get 16.6 is our p hat pool. Now we plug that into our standard deviation formula. Here we get standard deviation is 0.011117. And then we're going to, I just wanted you to see that. So using the standard deviation formula, technically, well, for z, we have to kind of our statistic, we really kind of do statistic minus the parameter here. Is the normal way we go. And this is our stat, right? P hat of the teens in 04 or 06 minus p hat, the proportion of teens in 94. So we're going to subtract those. In the parameter, the null is really 0 here, right? I mean, we're saying the null, nothing unusual. Those proportions are the same, so the null is 0. The standard deviation, we're going to, of course, use SE pooled, which we just talked about. That was this formula right here. So this is the formula that you need for standard deviation for pooled data. So that's our z value, -4. Right, so I would probably draw the curve. We know that's the middle of this guy is p hat, was it 06 minus p hat 94. We expect that null to be 0, right? So if our z value is -4, that's more than 4 standard deviations out here. That's very, very small. Little part right out there. 0.000026 is our p-value there. And so now we're going to start through with our concluding sentence and make a decision here on what we think have things, his hearing loss getting worse among teens. And so you start with something about the p-value. You want to say this in a sentence. Since the p-value of 0.000026 is smaller than the alpha level of 5%, I reject the null. P-value is smaller than the alpha. Again, you're going to use sentences for this, and you're going to reject null. We do have evidence to believe the proportion of teens with hearing loss has increased. So we do have evidence to believe the proportion of teens with hearing loss has definitely increased. So you want to say something like that as your concluding sentence. And that is how you do a test with 2 prop z intervals.